right, so, 11. All right, so I've been out for a couple of days. I'm a little bit sick. I'm back today. Gonna have your midterm exam done soon, okay? Probably by the end of this week, I have your grades posted. All right. But today we're gonna do the clicker questions for chapter 4. All right. So y'all know how this works. So we're just gonna go through this. These questions really quick, and we're gonna be done. All right. So to get those first few questions on that stuff, on the history stuff. All right. So the concept of free-falling objects applies to anybody? Both of the above. Right? So technically, the moon is because it's going around in a circle, that means it's accelerating. Remember I told y'all that? Because it's going around in a circle, the moon is always accelerating, right? So when you say free fall means something that's constantly in acceleration due to gravity. Okay? So if the moon goes around the earth, right, it changes its direction, which means it's changing its acceleration. It's accelerating, not changing, accelerating. It's accelerating, right? It's accelerating towards the center. It's changing its direction, okay? So that's why both are correct, the moon and falling hours. All right? What happens here? Quadruples. So it's the 1 over r squared, right? Remember what we talked about? Two planets, or in the case of chapter 4, we're talking about 2 planets. The further they are farther apart means what? Huh?
I said bless you.
Oh, further they are apart, that means what? The less they interact, right? So closer they come, right, means the more they interact. I'm wondering why they don't have an explanation here. But anyway, so that's a 1 over r squared relationship. So 1/4 would be 1 over what? 1 over 2. The distance between the 2 planets doubles, right? So 1 over r squared. So if I double r, 2r, right? I know y'all don't like this math, but it's the only way you can explain it. 1 over r squared, right? 1 over r, this is an inverse square relationship. Remember we went over this? Or do y'all not remember?
This is where it say intensity equals 1 over
Yes.
distance squared.
Yes.
Okay.
Yes. That's exactly it. Distance squared. Instead I call it r, instead it's called d, right?
Okay.
And so if I double d, then what happens? I double d, and I'm going to have 1 over what? 2d squared. Which is going to result in what? 1 over 4. start going?
Right.
Is that it?
Mm-hmm.
Or did I go to, huh?
That's this a new one.
Okay. If the distance between two planets decreases to half, what's gonna happen? Who said that? Quadruples. It's just this, right? So if it just the 4 is gonna flip to the top, right? Because it said if you cut the D in half, so instead of doubling it, right, I'm gonna just cut it in half, right? 1 over D over 2. Then square that. Following me? You square this, then you're gonna get what? 1. You're gonna get, I'm running out of room. 1 over, well, let me get up. Let's erase this one from last time. I'll do it again, right? So, huh?
Okay, so it would be 1 over the D over 2 squared,
Yes.
but the D would be 2.
No.
Would it be four over B squared?
Hold on a second. So it'd be, so we're gonna cut this to D in half, right?
Mm-hmm.
So we're gonna do the cut it in half.
Over.
Divided by 2. So it'd be 1 D over 2, right? Then you square it.
I was saying, so D in this equation is, if it's not 2, then what is it?
It's not 2. D is the distance. D is a variable.
I understand that, but I'm saying, are we, so like the last one, we like plugged in.
No, we didn't.
2 because it's half.
Huh?
Is that what you're saying?
Yeah, we're not trying to find D. We're trying to find what happens to the, right? If the distance between two planets decreases to half, the force of gravity between them. We're trying to find what happens when D is cut into half. What happens to that intensity you was just talking about? The intensity was 1 equals 1, right? What did you just tell me? Intensity equals 1 over D squared. So this is intensity, right? That is how intense the gravity will be between these two objects, okay? Now if I cut the distance, or if they here, I have a gravity, right? I'm gonna cut the distance in between them in half. So now they're here, right? So now I wanna know what is the difference between the gravity here and the gravity here. We're not trying to find D. We just said we use D as a variable to represent a distance. It could be any distance. Okay? So here, I'm gonna square what? Square the D, so it'll be 1 over what? D squared over 4. Right? Everybody following that? Okay, and so whenever I divide two fractions, right? See, this is where the problem comes, I think. Whenever I divide two fractions, what do I have to do? Huh? Okay, so I have to multiply the what? Huh?
Is it 4 over D squared?
Yes, so I have to multiply what? 4, well, 1, run out of room, 1, right? So this is like 1 divided by, well, I'm rewriting that over again, so I don't want to do that, right? So this is just 1 over 1 times what? 4 over b squared. Right? Okay? So the intensity quadruples. Y'all trying to reset the breaker at 129? All right, cool. Awesome. When the distance between two stars decreases by 1/10, the force between them does what? Oh, so now they got. So remember 1/10. When we square that, we get what? 100. All right. Everybody understand that? Okay. Same as. Now we're putting numbers to it now, right? Instead of. I mean, we can still use D, but now they got a number in there. All right, consider light from a candle. If it's 5 times as far away, its brightness will look about. Huh? I don't like this one. That ain't good. So all this is that 1 over that inverse square relationship, right? Meaning the further things are away, the less they interact. Closer they are, the more they interact.
So should we see?
You say C?
That's our next.
Okay. Consider a space probe at a distance 5 times the Earth's radius. As the gravitational force at Earth's surface. Its gravitational attraction. Good. Everybody understand that? Everybody got the logic and the reasoning for this? Good. All right, if the Earth's radius somehow shrunk, your weight on the shrunken surface would be, I don't know, if the Earth's radius somehow shrunk, your weight. That's, I don't know what that's something, that's not important. Okay. I got this though. Remember we talked about the bowling ball, when we put the bowling ball in the center of the sheet, the picnic thing, and the marbles are on the outside. I drop the bowling ball in the center, the marbles do what? Come crashing. Huh? So I think here you might have been thinking about the distance instead of the mass. Good. So, right? So we just doubled the mass here, right? And that's on top of the equation, right? It's not, the D is on the bottom. All right. Huh?
I think it's
thing is what?
Yeah.
Okay. Anybody else? Said more. Why you say more? No, you can't change. You can't change. I'm saying why you say more. You gotta give me a reason why.
But it's like an airplane, you weigh less, right? So like the higher up you are.
Yes. Right? Further you are away from the earth, your weight goes down. Right? So, you're on a ladder, right? And, you know, like a big ladder, right? You're like a ladder the size of a mountain. Okay? You're on that ladder, then yes, your weight will change because you are far away from the earth, from the surface of the earth. On your weight is a measure of gravity on the surface of the earth. That's what your weight is. When you're not on the surface of the earth, you will have a different weight. Right? According to the equation for gravity, if you travel far enough from Earth,
If you travel far enough, it'll reach zero.
alright, so that's just a little teaser question, I guess. Right? So it's essentially saying gravity never goes away. It never reaches zero. Alright? But don't worry about that. But you will reach infinitesimally small numbers. Huh?
Oh.
That's a good answer though. B is good. B is good.
Every time I get on
That group. If you're not in the group, you gone.
Oh yeah, we did talk about that.
Oh yeah. Oh, okay. So now I know how to do it now. All right. So this is like the third law, right? So when you sitting on the, what does the question say? When you stand at rest on a weighing scale, right? The force due to gravity on you is, right? It's just, right? If you're at rest, then that means you're no acceleration, right? That means A is equal to 0. So then that means every force that you experience has to be countered by another force for you to be at rest. And your gravity never goes away, which is the weight, right? Well, gravity never goes away. That gives you your weight. And so when you stand on the scale, right, and it has to have the equal amount of support force in order for you to be at rest. I think we had enough of these.
Wait, let us try.
Go ahead.
I guess it would be D.
Yeah, D.
Oh, wait. D. All of these.
Oh, yeah.
Because they in the space, so they wouldn't just. You don't have to support force, right? Okay, yeah.
Got it? Appreciate it. If the ball's speed was somewhat greater, the time to hit the floor would be
Less. It would be less. Because like the faster the quicker. I mean the heavier the quicker. Right? If the speed, yeah. Wait. Okay.
man, I thought y'all was gonna get that.
It hits the floor.
Remember we didn't talk about if I have a gun and I shoot a bullet and I drop a bullet at the same time, those bullets will hit the ground at the same time. Just in different places. If I shoot a bullet, huh?
You talk about the trajectory point, about how when you throw it higher, it don't fall.
No, not that one. So maybe I didn't talk about that. Okay. So if I drop something, off of the side of the table and I roll something off of the side of the table, they're gonna hit the ground at the same time, right? Why? Because the acceleration due to gravity in this direction is the same for both. So if I drop it and I roll it off, right? I can't do it, obviously. Unless one of y'all want to come up here and do it, right? But if I drop, that's why I say a bullet. If I have a gun, if I got a gun, I shoot a bullet, and I hold a bullet in this hand, and I shoot and drop this bullet at the same time, when that bullet hits the ground, the bullet that I shot hit the ground too. That's because motion is broken into X and Y. And motion along Y is different from motion along X. The only motion along Y is due to what? Gravity. Period. That's why everything will hit the ground, will accelerate towards the earth at the rate of gravity. Everything. Now you're saying, okay, well, if I have a feather and a piece of chalk and I drop them, they don't hit the ground at the same time, right? Well, they're both still accelerating at 9.8. The difference is the feather has a different response to air resistance, okay? So if I have, right, so something that's rigid, right? A feather is not rigid, right? Feather is, that's why birds are made of feathers, right? Because they can pierce through the sky, pierce through air real easily. Air resistance doesn't affect them the same way it does us. That's why they can fly, right? So, but they still, that's like if a bird stopped flying, what happened? He gonna come to the ground just like you. Once they stop flying, they gonna fall just like you would if you was up there, okay? But the feather cuts through the air. That's why it doesn't fall like that, right? Everything else pretty much falls, cuts through air. Because everything else, well, not everything else, but a lot of other things, there's other things that behave like feathers too, right? They got other things, and not just feathers. There's other things that don't just cut through the air like that, right? But that's why the feather behaves like that. But technically, if we were in a vacuum and y'all know what a vacuum is? A vacuum is a space with no air. So that's space, right? Space is a space with no air. And so if we were in a vacuum, then the feather would fall straight to the ground just like the bowling ball would, because there's no air. So the way the feather is moving through the air, that's just the air resistance making the feather behave like that. Okay? So that's the answer to this question, right? The same. So there is no difference in the motion in this direction of this ball, if me just dropping this ball or me just rolling it off of the side of this table, right? Because when I roll it off, the only motion it has is in the X direction. No motion in the Y. Y'all following me? So if I roll it off the table, it's just like me doing what? Dropping it. Okay? And we'll get some more practice with that, because I think y'all still might not be convinced. All right. One of y'all got a sheet of paper and a textbook. Nobody got a textbook?
My schedule.
You got your what book? Let's see something. Let's see if this is gonna work.
Oh.
Right? You saw that? No. What was it? What happened? Huh? It didn't move.
Like with the book under it, the paper.
It just did what?
Yeah, it just went down.
It just went down. And when I take the book away, like a feather. All right? All right? So that's... All right. What time is it?
Also inventory. Y'all want to try that? So I got it. Did I get it wrong? I got the answer. Wait, so how is that not like what we just?
You say, how is it not?
Yeah, because that kind of seemed like the same example of what we just talked about. So if that's the case, then did you hear what she said, Professor?
You say what?
She said, is it because it involves speed? So I said, if that's the case, if we use the example of like dropping something and rolling it at the same time, if you push it faster, it's gonna fall faster or hit the ground faster. Then
Here.
yeah, but I'm just trying to
Well,
see why
it's
it's
around
two
at the
different.
same time but at a different distance because it has more speed. It would still
Yes,
hit the
yes,
ground.
yes, yes, yes,
What
yes.
you say?
But it might hit at a different, it's gonna hit at a different position.
It's still
Right.
the same.
In the
Yes,
Y
it will still
direction.
hit at the same time, but it'll be a further distance because there's speed. It's beyond the court. It's basically. It'll weigh it beyond the court. Yes, it'll still hit at the same time it would have hit the court.
This is a longer
originally.
distance. I kinda get it.
Alright, next question.
It's longer, right?
Yeah, that's a little bit too many things going on there. I wouldn't.
It makes sense.
Yeah, like we could, if you think about it.
Wait,
Huh? But this is with no air resistance, so if the speed greater, then it's gonna have some air resistance, correct?
Y'all look at his face. Wait.
How high above? If this is over test, I guess. See.
See,
That's not
see.
gonna be the answer.
I say E. If it's going 520 or
Okay.
C.
I say B too.
Can we show the expiration?
It don't have, oh wait, it might have.
yeah, I'm going with C.
Yeah. Cause you guessed. C is the go-to answer. That's good.
Hey, good job on me. I would've got it right first.
Oh, wait, this is not the equation that I had. Where did they get that equation from?
This is the universal gravitational constant.
Yeah, I got G, wait, you got M
It's
equals G,
it's N
M1,
times
M2 over D2
over D2.
D2? Yeah, I got that.
Yeah, this is the free fall right here.
Wait, so G should have.
You have KG.
I got L.
Where's that? Yeah. F equals G, M1, M2 over D squared.
No, this is from.
What is that?
This is from free fall.
Oh, we going back.
Yes.
Chapter 3.
Yeah. Y'all know like STEM courses are like stacked, right? You know that, right?
Oh, I actually have that.
Yeah, I know. So yeah, what you learned in chapter 2, you're gonna keep using it in following chapters. Not always, but sometimes. So that's from chapter. I think this is chapter. We did that in chapter 2 or 3. 2. 3 was momentum or something.
Yeah.
I'm going with C.
Can it
No, I think it is actually. I could be wrong, but I think it's C. I'm on the roll.
Yeah, I mean, I would have guessed.
That's not my go-to answer, but like, it just makes sense. Resistance.
Oh, y'all got that.
C.
No. Wait,
Yeah,
wait,
wait.
wait, no. I think it's D.
Wait, I think it is D.
It's
I
not
think
D.
it's all of the above in a second.
All of the above. No, 'cause I was like A and B sound, and then she said C. I was like, hold on. Yeah. Okay. Speed up the boat. It's B. Constant.
I'm going with D.
It's gonna be constant.
I'm going with
If it's
nothing.
not affected, wait, the speed of a boat is all rolling along a smooth alley.
None of the above.
Oh wait.
For me.
I'm about to start side mission again.
I ain't thinking about that. What?
Okay.
Because if the pins wasn't there, it would keep going.
Wait, not
Okay, how is it
So like, I'm saying if the pins wasn't there, it'd keep going.
Maybe because
So that's why it's constant and then not affected by gravity. It's not, yeah.
This ain't gonna affect you.
You on the ground.
No, it's because it's rolling across the surface. It's already on the ground.
But like, in order to stay on the ground.
Oh, they're saying
It
like,
gotta be.
But it can't.
you know how like
Gravity don't have
gravity's
nothing to
keeping
do with
us.
it rolling.
That's what y'all saying.
If I push it,
Yeah, I'm saying like
It's
if
gonna
it was
roll.
a gravity above, it'd be what was it?
right? If I come and push, if I push the motor bar, it'll roll. Don't have to
It
have
would
it.
stay on the thing if they were.
Yeah, it'd be still on the ground. Yeah. Gravity is for things that are in flight or in the air. You say I'm
I
live?
think they saying like gravity is on us right now. That's what they saying. No, for real, that's what I'm saying right now.
If we take away gravity, we gonna float.
But it's not none of it. But listen,
Yeah, a lot of these are like that.
but it wouldn't be none of the above because it's still constant.
Huh?
Next would either be B or C. Yeah.
Yeah, but yeah, gravity is the reason why you're technically on the ground. Yes.
So
Yes.
why is that not the same for the ball? That's rolling along a smooth alley.
So, yeah, that's. I mean, you know.
But if it's constant, how come sometimes when we roll along too slow, it stops?
What?
But it's a smooth.
Because there's friction. That's why I said smooth. See, that's why I said
Actual bowling
these.
alley?
It's not gonna stop. It's gonna.
It's gonna keep going.
So Dr. Stewart,
It'll stop. It'll stop.
would
If
you
you roll it
say
slow, if you roll it slow enough, it'll stop.
would you say B is wrong?
I don't think so.
Huh?
Would you say B is wrong if we had just answered B? Would you say that we were wrong? Huh? Because you great.
Yeah, that's what I said.
Horizontal acceleration.
It's gonna be zero
So,
because
Why they got?
it's zero because the what do you call it? The x, the y is the same. The y is the same for all, right? So it's zero. Or
I'm locked in. I'm dialed in.
right, it's still C.
No, God is still C.
I'm dialed in.
Without air resistance.
Okay, I wanna say A too, but it say without air resistance, and is that not the thing for air resistance? So wouldn't that cancel out?
So when the
Yeah, so then I would say,
so it's B.
B. It's C.
yeah, okay, okay, look at our brains. It's today.
We dialed in, y'all. Good job.
We don't need no shot.
Okay, so then
Okay, this is
that is it. Wait.
With air resistance, so A.
A.
Oh.
Okay, wait, let's read it. Okay, then there is.
Oh, look, you gotta explain this one.
Okay, it lost me because it's comparing a ball and a feather, and we just talked about how there's two different things, so this just lost me.
So let's see. More than the time going upward, that is the time for a vertically tossed ball to return to where it was thrown. It's more than the time going upward. Well.
Or maybe a different explanation, because that explanation I can't do.
Well, if there's no air resistance, then we know it's both. It's the same, right? That was the last question, right? right?
Yes, sir.
The last question said it was the same, going up and coming down without air resistance. So if there is air resistance, right, then air resistance is, so
Oh,
It's
that's
gonna-
all the paper and the book example, right?
Well,
Which one
yeah,
would you say?
yeah, right? So, if you think about air, so when you throw up, right, it's working, it's working against it, right? I'm trying to think of something, a better explanation though. Cause that don't really, cause some people will say, oh, well, if it's working against it, then on the way down, it's working with it, so it should be less, right?
But it's working against it either way, right?
Huh?
It's working against it either way, right?
No, it said more, right? More time going upward.
It is working against it either way, but more coming down, I think.
Wait, more.
I thought more
No,
going up.
No, it's working, coming down is working with it, right? Gravity.
Oh, yeah.
Well, no. Well, gravity is, but air resistance. I'm confusing the two, right? Air resistance is different from gravity, right? So the air resistance. So it's So you're right. It's working against it going up and against it coming down. You're right, right? So that's why I was kind of like that ain't really explain why it's more time going down, going upward. Yeah, I'm gonna have to think about that. More than the time going upward. Cause like I say, if you're throwing it up, the air resistance, it's working against it in both directions, right? But the gravity, well, maybe that's the difference, right? Yeah, gravity is working against it when it's going upwards, and gravity is working with it coming down. Although you still have the air resistance either way. So that's probably the best explanation, I'm thinking. Yeah.
Okay, I think it's C. No, that's true, because of my notes.
Period.
Think it's C?
Because my notes say horizontal and vertical component is needed.
I think it's what's the right? No. B. Sorry. Invert. Because you said the Y. Why don't you? Don't.
Anybody else?
Don't make me mad. I'm scared. Me too. I'm scared.
Maybe we'll wrap up right here.
Okay.
If I'm wrong, we doing another quick.
Anybody else?
Please be good.
Oh. Okay, come on now. Okay, my notes, no, we don't need you. We've been doing good all class.
You
Maybe
come
you
to
do
work
it.
early.
Because the air resistance is the Y, so that's what's being forgotten about, and the horizontal component still stays, right? Huh? Because vertical is like, you were saying it's X and Y, so if the air resistance is the Y, then what we're keeping is the X, which is the horizontal.
Because it's always gonna go
Right.
horizontal.
And so, acceleration in the horizontal is always like applied, like I have to put a force on something to make it accelerate in this way. But in the vertical,
You got gravity and all that.
gravity is always there. I don't have to apply a force to anything for it to move vertical.
So the component that doesn't change is
No,
vertical.
it's horizontal, because the air resistance is being forgotten about,
Oh.
and that's up and down.
Acceleration is the change in velocity.
You don't get to come.
No, it's good.
You late.
That's it.
So
Yeah.
Okay, we need to. We also need some
We're almost done anyway.
I need some bonus.
I have a question.
What happened to the bonus points for the first song?
Yeah, ain't number two people do that.
Wait, no. What?
It's when
It was like
it's
five
when
of us
five
came to
of us
class.
is here.
And nobody else showed up, and you was
Oh,
like,
now
sign
you
those
know.
up.
You should have put it in writing. You should put it in writing.
Can I chapter 1 and 3 open on Pearson, please?
Yes.
Thank you. Yes.
Thank
1 and 3. It's
So
2
the
and 3. I already did one. I think you should just
The
open them
bonus
all.
point.
Please.
Are we doing both of them from the question and from that day when no one else came?
See, it wasn't just.
It's just
I'm telling you, it was like 5 of us here, and you said we get bonus points because we was here.
Oh, yeah.
We had attendance and everything, signed the roll and everything twice.
Well, we'll talk about it.
okay.
Okay,
Wait, so
this
you
is my
opened up the
question.
Pearson again?
Yeah. 1 and 3.
Yo,
You know,
2
just
and
open
3.
all.
I already did-
Everything. 1, 2, 3, please.
1, 2, and 3.
I already did one. I didn't know about 2 or 3.
Alright.
Whoa. It's huh? We got homework on Pearson?
Oh my God!
See, that's exactly why you want it open, Sean.
I feel like we should open it. That's why, so we
I
can review.
heard
So we
about
can
one.
review it.
I heard you say. I heard about one. I didn't hear about 2 or 3.
I'll open it.
Thank
Thank you so much.
Okay, this is my question. I got a tutor for this class. What is something that we could go over, or like where could she find stuff to help me?
You don't have your book?
That's,
Should I read one?
but isn't that
Shout out to
this?
Mom.
I'm saying like more questions instead of like.
This is plenty of them.
Oh, okay.
It's,
Well, actually, no, I think this one
I
is
don't,
small.
these are questions that they give to the instructor. Like the ones in the book, I don't even.
He got
It
no
might be
pants, so
different.
he was trying to
Okay.
get me. I don't know
Yeah,
how to feel.
so
You
Actually-
get them out. You can
try
bring
to
it, I
text me.
guarantee you.
Okay.
That's
Can
the
I
best
have them?
thing.
There are everything's in my room, but y'all don't really come to my room, so it's like.
What?
She be like, why we going to my room? Why we not going to yours?
No, wait, no.
I did all my homework, y'all, and I failed every one.
That's crazy. That's crazy.
Because I was trying to study for my test, and I didn't want to cheat.
What the?
The test, the midterm that we had, so
Come on,
I,
last week or whatever?
so I did my homework and I got a 16.
Damn.
Yeah, I think with chapter 1 I got like a 70.
One of my homework assignments, it say